In the first part of the lecture, we'll take a look at algebraic long division of a polynomial. What's a polynomial, you may ask, and what will we divide it by, and why do we want to do that? Let's answer each of those questions in turn. A polynomial is a single variable function of the form f of x is equal to c0 x to the power of n plus c1 x to the n minus 1, and so on. N, the exponent of x, is a positive integer, and it's finite. So the polynomial is the sum of a number of terms containing positive powers of x. c0, c1, and so on are constant terms. The degree of the polynomial corresponds to the highest power of x. So say, for example, the highest power term in your polynomial was 3x to the power of 6. The degree of the polynomial would be 6. What are we going to divide this polynomial by? Well, usually we want to divide it by another polynomial which has a lower degree. And typically, and this is what we'll look at in this lecture, the division of a cubic polynomial by a linear polynomial. Why do we want to do this? Well, one of the reasons we want to do this is to solve polynomial equations. If we have something of the form f of x equal to 0, that's a polynomial equation. These arise quite often in science and engineering, but we can only really solve them this way manually in the simplest of cases, and you'll find that in most practical applications you'll need a computer program to solve the polynomial, because it would just be too complicated and time-consuming to attempt to do this manually. And there's lots of software out there that will do this for us. To get started then, which of the following are polynomials? The first one seems to fit in with our description. It contains all positive powers of x. So it's a fairly safe bet then that the first expression is a polynomial. What about the second one then? 1 over x has a negative exponent, doesn't it? Because 1 over x is equal to x to the power of negative 1. So this can't be a polynomial. X is a polynomial. Cos of x is not a polynomial. It's a trigonometric function. And perhaps surprisingly, 0 is a polynomial, because the polynomial consists of coefficients and powers of x, and if all those coefficients are 0, then we'll have a polynomial which is equal to 0. Let's have a look at some special names of polynomials. If it's of degree 1, that is, it contains x to the power of 1, it's called a linear polynomial. If it has x to the power of 2, quadratic. X to the power of 3, it's cubic, and so on. There's names of 4th order, 5th order, and so I'm sure you'd be able to find some of those if you were to look on the internet. How do we go about doing this division then? Well, we're going to divide a polynomial function by a linear expression. So we write it out as I've shown. The dividend is the function which is underneath the division symbol, x cubed plus 2x squared minus 5x minus 6, that's the dividend. The divisor is x plus 1. When we do the division, we're going to write what's called the quotient on top of the horizontal line above the function. Let's do that. X into x cubed is going to give us x squared. So let's write that up on the top. Then we multiply out the divisor by the x squared part of the quotient. So we get x squared times x is x cubed plus x squared. The next step is to subtract what we've written from the original function. So we'll have x cubed minus x cubed is 0, and 2x squared minus x squared is going to be x squared. Now we repeat this process, but this time we divide the x into the x squared that we've just written down here. So x into x squared, that's going to give us plus x, and again we multiply out, so we'll get x squared plus x. As before, we subtract these terms, so we'll have x squared minus x squared is going to be 0. We won't write the 0 this time. And we'll have minus 5x minus x, and that's going to be minus 6x. Next we say x into minus 6x gives us minus 6. Multiplying out again, we'll get minus 6x minus 6. Then we do our subtraction, minus 6x minus 6x is 0. And lastly, for the constant term, subtracting negative 6 from the negative 6 in the dividend, obviously that will give us 0. So the 0 that we've written down at the bottom here, that's called our remainder. So in this case, the remainder is 0, or you could say there's no remainder. So in fact, we can rewrite our function fx as a product of the divisor x plus 1 and the quotient. So it'll look like this. F of x is equal to x1 into x squared plus x minus 6. X squared plus x minus 6 will split into two linear factors, and we can write that as x minus 2 multiplied by x plus 3. So we can factorize f of x completely by writing it as a product of three linear factors. The original factor is the divisor that we had, x plus 1, and then we've got x minus 2, x plus 3, which we factorise from the quotient. Let's take a look at another example then. Again, we set up our division like this, and we have our dividend x cubed minus x squared plus x minus 1 underneath the division symbols, and the divisor x minus 2 out on the left-hand side. So we begin by saying x into x cubed goes x squared. We multiply out again, and we'll get x cubed minus 2x squared. Then we do our subtraction. So the x cubed minus x cubed is 0, so we won't write that. Minus x squared minus 2x squared is going to give us plus squared. Then we have x into x squared will give us plus x. Multiply out again, we'll get x squared minus 2x. Subtract again, we'll get x minus 2x is going to be 3x. X into 3x goes plus 3. 3 times x is 3x, and 3 times minus 2 is minus 6. So this time when we subtract the 3x from the 3x, obviously we get 0, but minus 1 minus minus 6 is going to leave us a remainder of 5. So we can write our function in this form. F of x is equal to the divisor multiplied by the quotient plus the remainder, which is equal to 5. Now have a go at the multiple choice question.